find some socks. Here's one. What the heck? There's some math equations in here. I better go solve these.
Go.
I wonder how I solve these equations. I better look it up online. Okay. Go see Dan. Alrighty then.
Can you help me with some math?
Okay, Ben. I'm going to teach you how to solve quadratic equations by factoring. The first step you need to do is make sure one side equals 0. And the other side will have all the other numbers on it. Okay. And since we're factoring a trinomial, the answer should be in two groups of parentheses, which means like that. Okay. And next step is, since the x is squared, the first term in both groups of parentheses is x. Okay. And the next step is, now pick two numbers that multiply to 15 and add to 8. And then the two numbers will equal -3 and -5. Then make both parentheses equal to 0 and solve.
Okay.
Now solve this example problem I've created for you.
Okay. First step is to make sure it equals 0. 0. Then I have to make two parentheses. Okay. And then I have to put an X in the beginning of each. Now, what times to be 15 and adds to be -8? Huh. Maybe a -3 and a -5. Okay. -3 and -5. Did I do it right?
Yeah, it looks right to me.
Alright, thanks, Mr. Patty.
You're welcome, Mr. Dover.
Alright.
Oh shoot!
And his name is John C.
You forgot to solve the equations.
Okay.
And make each equation equal 0.
Oh, sorry. Okay, time for the next equation. Let's see here. Go see Eric. Alright. Gotta go see Eric. Go! That's right, that's right. Can you help with some math?
Ready to learn how to solve equations by taking square roots?
Yeah, Eric.
Okay, there's 4 simple steps. The first step, get the perfect square alone on one side of the equation. Then you use the square root property. Then you simplify all the square roots and write the square roots of the negative numbers in terms of I. So if there's a negative number, you write an I. And then you solve for the variable if necessary. So, the exact definition of solving with the square root principle is the concept of principal square root cannot be extended to real negative numbers, since the 2 square roots of a negative number cannot be distinguished until one of the 2 is defined as the imaginary unit, at which point and can then be distinguished. Got that?
I got that, Eric.
Okay, now do that example problem.
So we got that good perfect square. Get that good sign. Good sign. So we got that x equals, let's see. So there's a negative, so I gotta take out an I. And then since it's not a perfect square, I gotta make it an outside number and an inside number. So 50, 25 and 2, and 25 can go down more, so that's 5 square root thing in my bobber 2. Okay, I just gotta add that plus or minus sign. X equals plus or minus 5I square root 2. How's that look?
Good. Just remember that the reason the exponent of 2 goes away when you square root is because it's doing the opposite operation, so it cancels it out.
Okay, thank you, Mr. Sean.
Look at that. It's beautiful.
Okay, let's figure out this last equation, knock it out. Says we go and see Cecil Beaver. Alright. What if you still like...
Go.
Man, all this math is really cooking my eggs.
Oh my gosh, you're so freaking lazy. And all you have to do is make x equals negative b plus or minus, put the radicand over b squared minus 4ac, and that's the discriminant, and then you have to divide that by 2a.
Okay.
You get it?
Yeah, I guess. What do you want me to solve first?
Okay, for the problem you have to plug in these numbers. It's going to be x squared plus 4x plus 7 equals 0. And then, okay, what this first x squared equals a, 4x is b, 7x equals c. Oh my gosh, do you get it now?
I get it.
Okay, now plug it in. Plug all the numbers in.
There's a 1 right there, I get it.
Yeah.
Okay.
Oh my gosh, you're such an idiot.
Negative 4 plus or minus square root of 4 squared minus 4 times 1 times 7 all over 2 times 1. Is that right?
Yeah.
Okay, now do you want me to solve the discriminant?
Yeah, you probably should do that.
Okay, I will. Okay, so that's 4 squared minus 4 times 1 times 7. So 4 times 4 is 16 minus 4 times 1, that's 4. Then times 7, that's 28. Minus 28. 16 minus 28. 10, negative 12.
Negative 12.
So that means there's 2 imaginary roots, right?
Yeah.
Okay. Now do you want me to solve just the whole thing?
Yeah. You should probably do that too.
Okay. Negative 4 plus or minus root of negative 12, because I've already done that. All over 2 times 1 is 2. Then negative 4 plus or minus is I. So 2I3 all over 2. And 2 can come out of all those, so it's a negative 2 plus or minus I3. Oh, no, more underneath that. So it's negative 2 plus or minus I3.
Yeah, that looks right to me.
Alright, thanks. Finally finished all that math. And now I can go to sleep.
Oh my gosh, I was in here first.